In this video, we're going to talk about what is a polynomial. But if we're going to define what a polynomial is, we first need to define what an algebraic term is, because polynomials are made up of algebraic terms. So an algebraic term in one variable, and we're going to let that variable be x for the purposes of this discussion, is an expression of the form a times x raised to the n power. So an algebraic term is something that looks like this in general. Now the a of the algebraic term is called the coefficient. The coefficient is just the number in front of the variable, and that coefficient always has to be a real number. And the n in this expression is just the exponent of the variable, and that n always has to be a whole number. Some examples of algebraic terms include 3x, 4y to the ninth, negative 3/4 x to the third, and 25. Let's see if we can identify the coefficient and the exponent of each of these algebraic terms. The coefficient of the first term, 3x, is 3. The coefficient of the second term, 4y to the ninth, is 4. The coefficient of the third term, negative 3/4 x to the third, is negative 3/4. And the coefficient of the last term, 25, is 25. We'll talk more about this in just a second. Now let's see if we can identify the exponents on the variables in these algebraic terms. The exponent on the first term, 3x, is an exponent of 1. The exponent on the second term, 4y to the ninth, is 9. The exponent on the variable of the third term is 3. And now we come to the curious case of the term, the algebraic term of 25. Let's talk more about this term in detail and why this can actually be called an algebraic term when it's really just a plain old number. Algebraic terms without a variable are called constants or constant coefficients. And the reason they're called constants is because they do not contain a variable portion. And because they don't contain a variable, they don't vary, and therefore they are constant. But if we really take a hard look at constants, these numbers without a variable, we can write them with a variable if we wanted to. In other words, I could say that 25 is the same thing as 25 times x to the 0 power. Now, writing 25 like this, 25x to the 0 power, makes it look more like an algebraic term. Wouldn't you agree? Because I have my coefficient of 25, and I have my variable portion of x raised to the 0 power. But 25x to the 0 power is the same thing as 25. Why? Because we know that any number raised to the 0 power is 1. So really this is 25 times x to the 0, but 25 times x to the 0 is 25 times 1 because x to the 0 is 1, which means that 25x to the 0 is just 25. So for this example, the number 25, the exponent on the variable is actually 0. And the coefficient is the constant itself, 25. So now that we know what an algebraic term is, let's talk about what a polynomial is. That was the whole point of this video. A polynomial is just an algebraic expression that is a single algebraic term or the sum of several algebraic terms. So really a polynomial is just a string of algebraic terms. So let's look at these below and determine whether each expression is a polynomial or not. Let's look at the first expression over here on the left. X squared plus 2x plus 1. remember, for this expression to be a polynomial, each term in the expression must have real numbers as its coefficient and whole numbers as the exponents. In this expression, x squared plus 2x plus 1, the first term is x squared, the second term is positive 2x, and the third term is a positive 1. Let's look at the first term, 1x squared. Does this term have a real number coefficient? Yes, it's 1. Does it have a whole number exponent? Yes, it's 2. 2 is a whole number. So far, this expression looks like it might be a polynomial. Let's do the same thing for the second term in the expression. This term has a real number coefficient of 2 and a whole number exponent of 1 on the variable, so we're still in good shape. Now let's check the third term. This is the constant term 1. The coefficient is 1. And the exponent on the variable, remember, we could write this as 1 times x to the 0. So that means that the exponent on the variable is 0, which is a whole number. So we do again have a real number coefficient and a whole number exponent on the variable, which means, yes, this is an example of a polynomial. Let's look at the second example here, 3x to the negative 1 minus 2x minus 3. This polynomial, I see 1, 2, 3 algebraic terms. But I notice a problem right off the bat. In the first term, the exponent on the variable is a negative 1. Negative 1 is not a whole number. So therefore, this is not a polynomial. Let's look at this third example. The third example contains 3 terms. The first one is 1/2 x to the third. The second one is minus 2.3x. And the third is plus 5. Now, I don't see anything in this expression that would disqualify it from being a polynomial. The first term has an integer coefficient of 1/2 and a whole number exponent of 3. So we're good. The second term, negative 2.3x, also has an integer coefficient and a whole number exponent. And then the last term, the constant of 5, well, the coefficient of that is 5. 5's an integer. And the exponent on that expression is 0, and 0 is a whole number. So this third expression is an example of a polynomial. Now let's look at the last example, negative 2x plus 3x raised to the 1/2. In this expression, I see 1, 2 terms. The first term, negative 2x, has an integer coefficient and a whole number exponent. So far, so good. But let's look at the second term, 3x to the 1/2. While this term has an integer coefficient of 3, the exponent is not a whole number. It's 1/2. So therefore, this would not be an example of a polynomial. Now that we know how to identify polynomials and we know what they are, let's talk about some special terms that are used to identify special types of polynomials. So the first term is monomial. Monomial is just what we call a polynomial with one single term. A polynomial with 2 terms we call a binomial, and a polynomial with 3 terms we call a trinomial. Now, if we're working with a polynomial that has more than 3 terms, we don't have a special name for it. We just call it a polynomial. So let's look below and classify each of these polynomials as a monomial, a binomial, a trinomial, or perhaps just a polynomial. In the first example over here on the left, we have a polynomial with 2 terms. This is an example of a binomial. In the next example, 7x to the 4th minus 5x to the 3rd minus 2, That's a polynomial with 1, 2, 3 terms. And we call polynomials with 3 terms trinomials. In the next example, we have negative 5 x squared y to the third. Now, this is something we've not seen before. Is it possible for polynomials to have terms with more than one variable? And the answer to that is sure, of course. So this is still an example of a polynomial, even though it has 2 different variables, an x and a y. The question is, how many terms are in this polynomial? Well, there's only one term. Negative 5x squared y to the third is one term. Because this has one term, we call it a monomial. And then last but not least, over here on the right, we see 1, 2, 3, 4 terms in this polynomial, and there's not a special name for a polynomial with more than 3 terms, so we would just label this one as a plain old polynomial.